Good morning, students, CCR kids. We are going to be going over skill 1 today, which is our first skill of the actual second semester. Hopefully you guys are in person. If not, this is for you. We are going to be relating our factors to zeros. Let's dive right into the notes. We have our vocab to start off. What we are going to be looking at today are factors of quadratic equations. And a quadratic equation is an equation that can be written in standard form as ax squared plus bx plus c, where a, b, and c are constants. And a cannot equal 0. And once we have this standard form, we can factor it, and what we're going to be left with are factors. These factors are a number or a variable or combination of both that evenly divides into another number or variable. So we can't have a remainder. So for instance, if our example was 18, we would have the factors of maybe 9 and 2 or 6 and 3. Anything that evenly divides. 9 and 2 will be the factors of 18. So these are our factors. If it's a variable, we could say that it is 3x. One of the factors of 3x is 3, right? Because if we divide 3x by 3, the other factor is x. So 3 times x gives us 3x. 9 times 2 gives us 18. If we have something like x squared, we know that one of those factors is going to be x, and the other one is going to be x. Because x times x gives us x squared. So we want numbers that break up evenly. We don't want decimals or fractions. And speaking of breaking these factors up, factoring is literally breaking these expressions into its factors. And they should always multiply back together to give you its original expression. So if I have something that has a factor of 3, a factor of x, and a factor of 9, if I multiply these together, I will get 27x, which means that this should have been what I was breaking up in the first place. And when we get these answers to these factors, when we solve these factors, we're going to get these answers. These answers are called roots or zeros or X-intercepts. They're kind of interchangeable. They all relate to the same thing. So each factor is a solution to a quadratic equation, and we're going to look at what that looks like. And these can be called roots or zeros or X-intercepts. So let's take an example. We have a standard form equation right here. Standard form quadratic, 5x squared plus 22x plus 8. 5 is my A, 22 is my B, and 8 is my C. Okay, so I have an A, B, and C. None of them are 0. And we are going to factor it to get its factored form. We haven't looked at how to do that yet, but we are going to show you that this can be factored. And when we do factor it, we get these two factors, these two things in parentheses. And on a graph, what those two things are going to look like are right here. These are our solutions, where it crosses the x-axis. They are our roots or our x-intercepts. Ooh, can't spell. There we go. Intercepts or our zeros. They're all the same. But these 2 points right here are what we're actually looking for. And how do we get them? Well, we're going to solve those factors. And what that literally means is 2 steps. So once you have your factored form, which we have, we're going to set each factor equal to 0. Equal to 0. So what I really mean is I'm going to take a set of parentheses right here and set it equal to 0. So 5x plus 2 is equal to 0. And I have x plus 4 is equal to 0. And then my second step is I'm going to solve for x. For each, or for all factors. So right now I have 2 factors, so I'm going to solve twice. I have 5x plus 2 equals 0. Subtract 2 on both sides using inverse operations. That gives me 5x is equal to negative 2. And I divide by 5 because I need x by itself. It gives me x is equal to negative 2 over 5. And that is one of our factors. Or that is one of our solutions, sorry. And then I will take my other factor, x plus 4 equals 0, and solve for x. I'm going to subtract 4 from both sides. That gives me x is equal to negative 4. That is my other solution. And if you look over here, we write those solutions as an ordered pair, right here, where x is negative 4 and y is always 0. For instance, this one is negative 4, 0. And then negative 2 over 5 actually is negative 0.4, and y is always 0 for these answers. So that's all it is. Let's look at a couple of examples on what you might see on the SAT, and then we can compare them to how they will be framed in your homework. So for our delta math example, it says, determine the x-intercepts of the following equation. Okay, so x-intercepts we know are roots, solutions, they're zeros, they're all the same. So when it asks for x-intercepts, it's asking us to do the same thing as if it were asking to do the roots or the zeros. I'm going to take each set of parentheses, each factor, set it equal to 0. And then I'm going to solve. This is my step 1. And then step 2 will be solving them. I'm going to add 2 to both sides on this one. Oops, there we go. This will cancel. And it gives me x is equal to 2. For this one, I'm going to add x to both sides. Negative x and a positive x cancel out. And this becomes negative 4 is equal to x. You can rewrite that as x is equal to negative 4. Okay? So on our SAT, it says, given the polynomial above, what are its zeros? Well, asking for the zeros is the same thing as asking for the x-intercepts. They just framed it the same way. So we're just going to take all of our parentheses, each set of parentheses, each factor, and set it equal to 0. X minus 7 equals 0. X plus 5 is equal to 0. 2x minus 3 is equal to 0. So we have 3 sets of parentheses, 3 factors, so we should have 3 solutions. So I'm going to add 7 to both sides on the first one, and that's going to cancel out. That gives me x is equal to 7. I'm going to subtract 5 from both sides on the second equation, and that's going to give me x is equal to negative 5. And then I'm going to add 3 to both sides on my third equation. It gives me 2x is equal to 3. I need x all the way by itself, so I have to divide by 2 here. That 2 is going to cancel out, and that's going to give me x is equal to 3 halves. So these 3 answers are all solutions. They're all roots or zeros or x-intercepts. They're all correct. In our second example, we're going to get a little bit more complicated. I did not catch this when I was making the slides, but this is not an addition symbol. This is a subtraction symbol. But what we're going to do is the same thing. It says solve for all values. So it's asking us to solve those equations. Solving for all values of x is the same as the roots, intercepts, so on and so forth. I'm going to take each factor. And this negative 3 sitting out front is also a factor. So I'm going to set that equal to 0. Well, this is not possible. So this is not a solution. We still have to count it among our sample size. We have to equate for that possibility because it is technically a factor. I'm going to take x plus 6, set it equal to 0. And I'm going to take x squared minus 49 and set it equal to 0. And I have to solve all of these. I'm going to subtract 6 from both sides. And that's going to give me x is equal to negative 6. Not bad. And then for this one, I'm going to add 49 to both sides. And that's going to give me x squared is equal to 49. Now, the inverse operation for squaring something is the square root. So I'm going to take the square root on both sides. The square root of a square is x. So x squared and its square root is x. Square root of 49 is actually 2 numbers. It is negative 7 and positive 7. So we write those as plus or minus 7. And that just means that if I have negative 7 times negative 7, I get 49. And if I have 7 times 7, I also get 49. So this answer actually gives us 2 solutions. So these are this is 2 solutions, and this is a solution. So again, we have 3 factors, we have 3 solutions. And in our SAT example, it says the polynomial function f is defined as f of x is equal to 3 times 5x plus 3 times x plus 2 times 7x minus 1. And it says, what is a solution to the function? A solution. So we just have to find one. I'm going to do all of them just for you guys, and then I will decide which one would fit. So normally in an SAT question, they would probably give you a multiple choice. They would say A, B, C, and D, and they would say like, which one of these is a solution? And so they would give you like 2 or 5/3 or 1/7 or 3. They would give you all these options, and then to figure out which one of these would fit, you'd have to solve for all of them. So we're going to set 3 equal to 0. That's not a solution. So I can count that out. 5x plus 3 is equal to 0. I'm going to solve that one. Minus 3, minus 3. 5x is equal to negative 3 divided by 5 on both sides. X is equal to negative 3 over 5. That's not one of those solutions that's listed. X is equal to, or x plus 2, I'm sorry, x plus 2 is equal to 0. Let's subtract 2 on both sides. That is x is equal to negative 2. So I have 1, 2 right here. I'm going to guess that that's probably not right. I'm going to guess that that's not right. So at this point, I'm probably going to choose C, but we're going to solve just to be sure. I'm going to add 1 to both sides. That's going to give me 7x is equal to 1. Divide by 7 on both sides. X is equal to 1 over 7. So this one is a solution. These are all of the solutions that we could possibly have, but from our hypothetical, only C was the correct answer. So we have a couple of view tries for you guys to go through. I'm going to give you a second to do that, and then I will come back and show you how to solve it. Okay, so we have 2 factors, so we should have 2 solutions. X minus 2 is equal to 0. That's our first step. We set it equal to 0. And then we have negative x plus 5, and then we set that equal to 0. And we solve both of these equations, and that should give us 2 different answers. I got x is equal to 2, and 5 is equal to x, which are our 2 factors. Okay, so this question says, how many distinct roots does the equation above have? What it's actually asking you is, which is what I put down here at the bottom for you guys, is what are the individual roots? The roots are, remember, the solutions to our factors. So it's just asking you to set these factors equal to 0 and solve them. Go ahead and take a second to do that, and then I will fill in the blanks. Okay, so here are our solutions. We've taken each factor and set it equal to 0. I have x is equal to 2/3, x is equal to negative 3, x is equal to negative 1/2. These are distinct roots because all of them are different. They're not. I don't have x equals negative 3 twice or whatever. So I just count the number of solutions. I have 1, 2, 3. So the answer is 3. How many distinct roots does this equation have? It has 3 distinct roots, and these are those roots. And now we have a challenge problem for you guys. This is something we're going to talk about next class, but I wanted to see if you guys could kind of start working towards it. I've given you the factored form, and I want you to move backwards to the standard form of this. To do that, you're just going to multiply all of these factors together. So go ahead and take a second to try that, and I'll show you what I did. Okay, so I have presented you with 2 different methods for solving this. The first one is the distribution method. What I'm going to do is I'm going to distribute this 2 into x plus 2 and get 2x plus 4. Then I'm going to distribute that into my x plus 3. I'm going to get 2x squared plus 6x plus 4x plus 12. 6x and 4x are like terms, so when they get added together, they combine to 10x. If you are not confident in distributing, there is another method called the box method where you take each factor. So I have 2x plus 4 as one factor and x plus 3 as one factor. And I multiply them together in a box. So 2x times x, 4 times x, 2x times 3, and 4 times 3. These give me the same terms, and then they can add to the same answer. I hope this helped, and please look forward to seeing your IP on Wednesday.